Hey guys, welcome to the class here. Thank you for joining on time, first of all. I'm going to begin within the next 30 seconds. Let's give others enough time to join in. And thank you. I really appreciate you joining on time. So 30 more seconds and we'll get started here. So as you all know, we are going to cover laws of motion from ninth CBSE perspective. Whether or not you have done laws of motion earlier, you are at least going to become a super duper expert in second law of motion today by the end of 1 hour. So just stay tuned for 1 hour, guaranteed. 60 minutes of your time is going to be a lot of precious time investment. And I see a lot of students joining in. There is a big number of students I see in the class today. Oh, that's a good news. More joining in. Thank you. Thank you, everybody. Thank you for joining on time. So we will get started in 15 seconds from now. Next 60 minutes are going to be really a big investment, time investment for you. Okay, guys, let's get started now. Before we start, let me introduce myself. Some of you might have already taken classes with me, some of you might be completely new. So, this is Bhavdeep Singh. I live in the beautiful city of Chandigarh here. I did my master's in technology in IIT Bombay from 1998 batch, and none of you was born that time, right? So I'm really old compared to you. Um, I was working and then I quit my job. I'm a full-time teacher for past 5 years, but I have been teaching before that on a part-time basis. I have helped shape thousands of successful careers here. People achieve full grades in their exams and do competitive exams, JEE, NEET, and all sorts of AP exam, SAT exams, and all that. The reason I'm sitting here right now is because I love physics, I love kids, and I love teaching physics to the kids. And that is the only reason I'm a full time teacher right now. I want to impart the knowledge of physics to as many people as I can. And kids, not only you can call your parents next time, they can join the classes, learn some physics from me. I would be very, very happy to teach them as well. My mission is make my students fall in love with physics, and you cannot enforce love, right? The way I try to do that is make physics fun, and then if you were not loving physics, making it fun is going to make you love physics. I mean, that's one of the missions of my life. So with that getting my introduction here, let's introduce aaj ka agenda today, right? So today's agenda is to make you an expert. I'm repeating the word expert in Newton's second law of motion. I'm repeating it. In next 60 minutes, you're going to become an expert in Newton's second law of motion. Now, there are two surprises in the class coming up. So, for the students who stay tuned for next 60 minutes, you don't want to miss these surprises. They're really, really, I mean, you will appreciate, you will thank yourself. Okay. Now, there is a lot of fun that I can guarantee. I think that is hidden behind my picture here. Yeah, so there is a lot of fun that I can guarantee you in today's class. So, that is another thing you should stay here. This is not going to be a boring session. So that is Aaj Ka Funda. So let's get started with the Aaj Ka agenda, not funda, but the agenda, with a tiny little brain exercise here. So guys, please read the puzzle here and reply on the chat box. This ancient invention allows people to see through the walls. I already see some answers coming in here. Thank you, guys. All different sorts of examples. See, the reason for this puzzle is not to certify somebody. The reason here is when I give these kind of puzzles, students really think out of the box. That's some students are saying a mirror or a magic mirror or magic paint. That's another good one. Thank you for that. Yeah, please reply on the chat box. What is an invention that allows people to see through the walls? Think. Another 10 seconds, please. Yeah, all different answers coming in. Thank you for that. The answer I had in my mind, I mean, it's all the answers here appreciated. Everyone has thought out of the box. The answer I was thinking is a window. Make a window, you can see through the walls. In my class, I try to make students speak up by this, and it's also a little challenging, brushing up, flexing your brain muscles, but then also making you think something out of the box. And it actually helps me. It really helps me to make the conversation started as well as get some out of the box answers here. Thank you for that. So let's get started with the journey of second law of motion. But wait a second, why second law of motion, right? Because we usually start with something like first law, you should do second law, and then the third law. So what's so special about second law that we are going to study the second law? The reason for that is twofold. First of all, second law is the only real law. So when you come to grade 11, this will be also in your curriculum, but then you should also know Newton has given us three laws, 1, 2, 3. Number two is the real law, in the sense that this is the law and you can derive first law from this, the second law from this, right? So it's more like Newton is repeating one thing three different times in different words, but that's fine. It's not that it's waste of energy. It's in different scenarios, maybe the words written in first law and third law are applicable also, right? But in most of the cases, I repeat, most of the cases, like 99% of your cases, you are going to use F equals ma, the second law that we are going to study today. And that is why we are studying second law. If you master second law, first and third is maybe a few minutes of my time, I can make you expert in that. So that is why number two, second is the best here. So let's get started with that. So what is second law? Okay, what is second law? F equals ma. Right. So that's it. Right. Many students, three students have already written, sir. That's not a law. That's an equation. What is the law? Okay. Yeah. The law is basically a statement there which says the rate of change of momentum is directly proportional to the force applied. Right. But from the point of view of what you are going to use in ninth grade, and most of the time you're going to use F equals to ma. So it's like I'm trying to simplify things for you by eliminating that statement, right? So F equals ma. This is the second law. So there are three responses already reading here or whatever. So they say, "Sir, this is a very tiny thing. I mean, that is it. It is tiny, but then small is beautiful and it is powerful too, right?" So this is the law. This is what we are going to focus today. And this equation, just note it down. You're going to use, if not less, maybe 1,000, 2,000, 3,000 times in next 4 years. You're going to use this here in mechanics. You're going to use it in electrostatics and magnetism. You're going to use it in many places. And this one tiny little thing is going to be used so many times in the rest of your career, maybe. And it's way beyond appreciating that. It's really powerful, and we will see the power right now. So just slow down and look at it first. F equals ma. What does this tell me? This tells me if I am applying a force on something and I know the mass of it, I can calculate the acceleration, right? So let's actually rearrange these words. It looks like A is equal to F over m. Fine. So I tell you the force I'm applying on this phone. I tell you the mass of the phone. You tell me how much is the acceleration. And this acceleration is what you studied in kinematics, where you said acceleration is the rate of change of velocity. This is what we are talking about here, if you do remember, right? So if my acceleration is 2 meters per second square, just let's revise that concept as well for a few students here. So let's say there is a ball, and this ball is moving with 3 meters per second. And let's say it has an acceleration of 2 meters per second square. What does that mean? I take a watch, and now, the velocity is 3 meters per second, and this number 2 meters per second square actually tells me the speed goes up by 2 meters per second every second. So 1 second later, the speed is going to become, yeah, thank you for replying, 5 meters per second. 2 seconds later, it's going to become 7 meters per second. Thank you. I really appreciate all those messages coming up in the chat box. Thank you for that. Now, this is what acceleration is, and this is what we are actually talking about here when we say F equals ma. So, given a force and given a mass, you can actually calculate how much is the acceleration. And that is it. Really, that is it. Okay, so let's also understand from common sense perspective. Maybe Newton gave us this law, but does it really happen in real life, day-to-day life? Let's see that. More mass, more acceleration. I'm not sure if you help your parents out in grocery shopping, but let's say you fill in the grocery in one of the baskets, one of the shopping carts there, and the other shopping cart is empty. So isn't this easier to? I mean, that's basically not even physics. That's more like common sense there, right? It's easier. So if you apply the same force on both of them, oh, this will just zoom. It's going to run faster, right? And this is going to be, oh, okay, moving, slow down, okay? So now another one is here, the force of the girl. Let's say girl is able to apply the same amount of force. It's constant. She can move this box very fast, a little slow, and very slow here, because there are 3 boxes down there now, right? So any confusions, you please let me know and we can discuss those. Okay, so let's continue to the next slide, and that is more like the other thing. So let's say we were here and we said F equals ma. So let's write here. So then we are saying F equals ma. So that actually gives me acceleration is force by mass, right? More the mass, less the acceleration, because in your mathematics class you have studied proportionalities. It's inversely proportional to mass. More one thing, and the inverse proportional thing is going to be less. So the more the mass, less the acceleration. Less the mass, more the acceleration. Now this one is ulta. So A equals F by m, Assuming the mass is constant now, assuming the ball here, 1, 2, and 3, and some students are saying blue color is better than red, so let me change the color to blue, because I know it really yeah, it stands out. So 1, 2, and 3. So ball number 1, ball number 2, and ball number 3, right? So they both have the same mass, right? Now, assuming the mass is constant, acceleration is directly proportional to the force. Means more the force, more the acceleration. So this tiny little foot here, maybe a baby here or a toddler there, pushing the ball, it goes with some speed. This person pushing the ball with a faster speed, and this person with a boot there, obviously more force, and the ball goes faster. So the more the force, more the acceleration. So it goes by common sense also, right? So this is the second law, and we are going to do a lot of questions today, and there are surprises for you in the session as well. So please stay tuned. If not for surprises, at least for becoming a super expert in second law of motion, which you are going to use in your career, many places, in your exams, everywhere. Okay. Now, another way to remember what's Puma. I'm really sorry I stole a trademark here. That was not the purpose, but Puma, right? The athletic sport wear manufacturer, right? So F equals ma, right? F, M, and A, right? So please memorize this. Don't memorize. Try to understand it at least today. So practice makes perfect. We will jump into questions. Today we are going to do at least, I think, if not less, 7 or 8 or 9 questions. And I'm going to give you challenging questions here. We are starting small. By the end of it, you're going to do challenging questions. So let's start with a tiny little simple question, giving you 10 seconds to answer here. Or maybe 20 seconds. Take 20 seconds. Yeah, thank you. 20 responses so far. Thank you for that. Very nice, very nice. So many responses coming in. Guys, some of you are giving the wrong response. You might want to reread the question. Please take your time, maybe another 10 seconds. I will give more time with the difficult questions. I'm just trying to show you that these kind of questions you can do in a jiffy. Cool. So most of the answers are now right. Yeah. So net external force acting on an object is 0. I usually make ugly pictures to get started with any problem. When I say ugly, don't mean really ugly, but at least something quick and dirty. Quick and dirty as in just to get me started here, right? So there is a body here. There is no force on the body. There is no force at all. Which of the following statements is true? You always use second law of motion. Force is equal to mass times acceleration. There's no force at all. Zero force is equal to mass times acceleration. Mass, you can take it on the other side. I'm going slow so that everybody understands it in this case. What do I get? I get a statement. I will use the red color here that acceleration is 0. In your kinematics, you have used all this acceleration concept and all that. If not, you really have to brush them up. Please revisit acceleration portion. Acceleration 0 does not guarantee that the object will be stationary. Acceleration 0 means velocity does not change. Now let's say the body was not moving, the velocity does not change, the body was stationary. It will continue to be at rest for the rest of its life. Maybe a zillion years down the line, it's not moving. But now let's take another box, maybe a green color box. And the box is moving with 3 meters per second. So we went through this scenario earlier, 3 meters per second. Now if there is an acceleration of 2 meters per second, in next 1 second it becomes 5 meters per second. Now because acceleration is 0, in next second the velocity remains constant. It does not increase, it does not reduce, it continues with the same velocity for the rest of the life of the universe maybe. So the object can either be stationary or traveling with a constant velocity. And congratulations, you have just now learned first law. This is the first law that we will cover later formally, but this is the first law. And as I was saying, second law is actually the law. First law and third law are coming from it. Right? Okay, so students are making a thumbs up there. indicating that this is super clear, I think. That's what I think. Maybe you're not giving me a tanga there. Thumbs up there, right? Okay, thank you. I will slow down here, give you enough time to work on it. We will spend like 3-4 minutes on this slide. Take a pen and paper. If you don't have pen and paper, go and grab it and then take it. So extra 1 minute for that, 2 minutes for question, 1 minute for grabbing the pen and paper. Come on. It's super easy. F equals MA. That's the only tool that you have. Oh, that was fast. Okay, thank you. Yeah, keep writing on the chat box. A few messages are wrong answers, and I'm really sorry. This webcam is coming on the way, maybe, of this question. Now it is clear. Thank you for pointing that out. Thank you. So many responses here. So let's work on this. And if you want people who are watching on YouTube, you can actually pause this video and work on it. For the students watching live, you may work on it later. For the students on YouTube, make use of the pause button there and pause this. Maybe take your time, 4 minutes, 5 minutes, maybe half an hour. It should not take that long, but do not go to sleep. Just work on this and then replay this. So let's get started here. Car of mass for one thing at a time. I really tell my students never mix and match, right? So never make a khichdi here, just one question at a time. So the first question is a car of mass 400 kilograms has acceleration of 2 meters per second. Calculate the resultant force. The one and only one tool that you have is F equals ma. F equals ma, right? That's all you have. Now, F equals ma means you have to calculate the force. So you just put the force there is equal to mass. Mass, I don't know, right? Mass is 400. Sorry, I take it back. I don't know what I was thinking. So mass is 400 kilograms multiplied by, actually I was reading the responses there. People are still super excited here. Everybody is giving the right answer there, right? That's all you have. 400 kilograms times 200 meters per second squared. Now that calculation gives me 800, but look at the units now. Kilograms, meter per second square. So the force is 800 kilograms per meter square, right? Now that doesn't really look like a unit of the force to me. At least it doesn't look like to me, right? Okay, yeah, thank you. So forces are measured in newtons, many students are saying. So make a note of this. I'll write it as a side note here. Kilograms, meters per second square is called Newton. To honor Mr. Newton, the great brain out there. Right? So then you can either write it like this technically, but you should always honor the great brains over there. Just say 800 newtons. Yes. So the second question now. Pause the video if you have to and take as much as time you needed and work on it. Couple of answers are wrong here. Most of them are right. Couple of answers are wrong. Reread the question. Read it 2 times maybe. You're making a slight error there. And the error is you have not converted this. This is grams. SI unit is kilograms, right? So then you write the same thing. F equals ma. Mass is 500 grams, but that is not SI unit. So I got to divide by 1000 and then write kilograms there. And then it's always a good idea to keep writing the units there. Boom. So then how much is this? That is 0, 0, 0, cut. So 5 kilograms meters per second square. That is 5 newtons. Clear, everybody? Okay. Now the third question here. Okay, so many students have already responded. So card of mass 5 kilograms moving with a constant velocity of 5 meters per second. I'm telling you 90% of the responses here are wrong. Reread the question. There is a little catch in there. Yes, now the right answer is coming in. Good job, awesome job. 50% students are right so far. I'm just counting blindly here. I'm doing just a guess here. At least half of the answers I can see are right. Yeah, the catch here is it says constant velocity. Many students have given the answer 25 newtons. What is force? Force is mass times acceleration. So mass is 5 kilograms. Let's write 5 kilograms. How much is acceleration, guys? It's moving with the constant velocity. Constant velocity means the acceleration is 0 and the force is 0 newtons. And then again, that is first law of motion. Right? So if it's moving with a constant velocity, it got to move with a constant velocity if the net force is 0. The force is 0. Now it's the time is like almost 20 minutes into the class. Within next 20 minutes, I'm going to give you a very challenging question. So be prepared for that. We are building up on that. And you're going to do that challenging question. The question is really challenging. But if you focus on these 5-6 questions before that, that question will be piece of cake. So be prepared for a very challenging question in next 19 or 20 minutes. I keep watching the watch here so as to honor your time. I will take your 1 hour and make you expert in second law of motion. Chale aage, second question here, or the third question. Practice makes perfect. So we are going towards perfection now. Yeah. Take maybe 1 minute on this. Don't rush. No rush. Do it formally. Write down the equation. Honor Mr. Newton on that. Write his equation. Start doing systematically. Because for exam, you have to show the responses, right? You have to show all the steps in there. Good answer. Yeah, good answer. Yeah, that's right. Yeah, I see 5 students have given the right answer, not written the unit. No unit is not acceptable. In physics, you give the unit wherever the unit is applicable. Not everything has a unit, but most of the quantities do have a unit, right? Yeah, so please give me the unit. Thank you. Yeah. So let's continue. Resultant force of 100 newtons is applied on a body. So make a body. The resultant force is 100 newtons. So please, I will sidetrack a little and tell you, 100 newtons doesn't mean this is 100 newtons. It can also mean that this was 150 newtons and this was 50 newtons. You get it? So one of the person is pushing with 150 newtons, the other one is pushing back with 50. The resultant is 100 newtons, right? But we are going to keep the thing simple here. So I'm saying this is 100 newtons and the body is accelerating with 2 meters per second squared. How much is the mass of the body? I do not know. In physics, if you do not know something, immediately assume a variable for that. If your name is Ayush, just you can assume the variable as A. My name is Bhavdeep, I can imagine or assume the variable as B. But it's always a good idea to use the conventions. Mass is usually taken as M. But if you take any of the letters there, it doesn't really matter to you. Right? But try to stick to conventions. Now the next step is just write down the equation. Fill in the values. I know force is 100 newtons. Is equal to mass is unknown. Multiplied by acceleration is known to be 2 meters per second squared. Take 2 on the other side. Cross multiply. Kachiguda, whatever you call it. 100 newtons over 2 meters per second squared is equal to mass. So 100 by 2 is 50. 50 kilograms is the mass. That is your answer. It's so simple. I mean, if it looks simple, it is simple, but it is very powerful. We are using it in the simple scenarios here. It will be used in complicated scenarios coming up. One of the questions that I will give you will be difficult. So stay focused, stay tuned. Next question here. Yeah, this one will need some mixing of dynamics as in F equals to ma and one of the 3 equations of motions that you learn. So I'm going to give you almost 2 minutes on this. Take your time. That's good. Answers are already coming in. But many answers are wrong. You're giving me the acceleration. I'm asking you the velocity. So do it one more time. You're halfway there. You have to walk the rest of the half journey. You're done. Half of it is done. I would say more than half is done. Good job, good job, good job. Keep doing that. Yes, yes. Keep giving it on. 5 answers are right so far out of maybe 25 answers. Yeah. For students on YouTube, you can pause that and then you can take as long as you want to. Our classes are usually live, and in there you chat with me live, but this is also on YouTube for the students who are not in the live session and they're watching it later. So this is a YouTube video also, with some of the students being participating live here. 7 answers are right so far. Out of, I would say, like 15 to 20 responses, 7 are right, and that is a good news. So far, that is good. Okay, so let's work on this together. There is a mixing of this chapter and the previous chapter, and that is why you read the kinematics part first and then dynamics part. So you have taken the first step there, this is the second step, but then you got to use everything. So in physics there is nothing like an isolation kind of thingy. So when you're working on a problem, you might be able to use concept from your one chapter, second chapter, third chapter, maybe 15 chapters there, and that is how you work in physics. And then you use your knowledge from the mathematics class also, right? So that's how the physics problem, real life problems are going to be. So we are taking steps over there, and then second law I can guarantee next 35 more minutes you are already getting there. Most of you are already there, the rest of you will be there very soon. I can see many of you are already there. So let's continue or start doing this question. Force of 20 newtons. I always make pictures. You can make a box. You can make a tree. A tree doesn't move. That's stupid of me. Maybe a table, maybe a chair, maybe a bicycle. Make anything. I prefer a box. You can make a person. You're pushing a person, right? Anything. A force of 20 newtons acts on a body. 20 newtons, right, of mass 5 kilograms. This gives you visual kind of, you really will appreciate this when you do difficult questions. When I would stack 5 boxes there, you really have to make the picture of 5 boxes there. Okay. Acts on a body, find the velocity after 5 seconds. So let's write down the goal. Velocity after 3 seconds, right? That's the goal of the question here. So we will work on the goal. But first, let's talk to Mr. Newton, and he tells me that F equals ma. Okay, F equals ma. We have already done so many questions here. So many students were telling me the answer to this. So A comes out to be 4 meters per second square. You're halfway there. The question says, so you have to look at the question carefully. It says, what is the velocity after 3 seconds? So once you have found the acceleration, you can use this information on the other side. So let's do that. Now, when you're dealing with accelerated motion, if you've taken classes with me, I usually teach you like this. I would say that you first blindly write these 5 letters here. Whether or not you know the values is not material. So main thing is you write down 5 variables because there are only 5 variables that we deal with. Now you start plugging in the values. Do I know initial velocity? Yes, assuming that it was initially at rest. You got to read every part of the question there. The body is initially at rest, and I can see the messages there. Students are saying, I do not know initial velocity, I cannot proceed. It is given there, right? Initial velocity is 0. What else do I know? Find velocity. So I would write the letter or the word here saying find. I have to find this. And then acceleration, just now I calculated. I can use this information there. Okay. Displacement, I don't care. After 3 seconds, I know the time is 3 seconds there. Now, after this, and if you've taken classes with me, I've told you that all the 3 equations have to be on your fingertips. And those equations I will write here: V equals U plus AT, S equals UT plus half AT square, V square minus U square equals 2AS. Very powerful equations. All these 3 equations have U and V, U and acceleration in them. This is part of all the 3 equations. Look at this. This has U and this has A. U and A, U and A. But in addition, they have 2 more variables, plus 2 variables. So in total, every equation has 4 variables in there. One is U, one is A, plus two more variables, right? Now you already know, you've done in maths, in order to solve one equation, there should be only one variable in there. So what that means is you should be having information about three things. And then you can calculate the fourth thing, right? So unless you know three values in here, at least three values, you should not be proceeding. Sometimes you're given three values, sometimes it is obvious. Like in the case of this watch, if I throw that down or leave it down, drop it down, acceleration will not be given to me in most of the cases, but then I know the acceleration is acceleration due to gravity in that case, right? So three things will either be given to you, or maybe two are given, one is obvious. Like when you drop this, two things are obvious. One is when you drop it, the initial velocity is 0. The second is acceleration is 9.8 or 10 meters per second square. So all I have to be known is one value only, right? Two are obvious. But that was another scenario. But let's work on this scenario for now. I have to find velocity, final velocity. Three values are given. So now you go hunting. You go hunting and say, oh, which one has all these four values? This one, no. V is equal to U plus AD. Yeah, this one, right? This one, no. This one, no. Some students have written to me third equation. No, it is not third equation. Because third equation is using displacements, right? That cannot be used. Now, second equation also is using displacement. That cannot be used. So the only first equation fits here. Then you start plugging in the values. V equals U plus AT. And this is the answer most of you gave me. And then I can see you're taking steps towards perfection in second law of motion. So I'm going to move on to the next question. Take a screenshot if you want, pause the video here if you want, go through this. Every question here, see, let me tell you what I'm trying to do at this point of time. I promise you I'm going to take you here. And we are doing this. We are taking 7 or 8 steps to that. By the end of it, you're going to reach that height where you can do any question in second law. And I'm going to give you a difficult question here. So if you have missed one of the steps here, one of the steps is one of the questions. If you have not understood it, it's really advisable that you pause the video, look at the question, try to understand this. I would rather say pause the video, look at the question, do it on pen and paper yourself, and then match what I have done. And then I can give the guarantee. Otherwise, there's a disclaimer. If you're missing a few steps there, I cannot guarantee that, right? So I can already see messages coming here. Sir, promise, promise, promise. Thank you for that. Giving you 2 minutes on this, please. Everybody has to participate. No sleeping in the class, no lazy, nothing. 60 minutes of active participation. Surprises coming in, 2 surprises coming in. Follow the kind of steps I did, or if you want to call them like the procedure, or you can make your own steps. In physics, at least with me studying, I will not enforce any steps on you, except sometime. Whatever works for you, works for somebody else, maybe does not work for somebody else. You're unique. You are unique. You make your own steps, your own procedures. As long as you stick to the conventions and the rules, you make your own steps. I can already see the answers there. 15 responses roughly, and more than 10 are correct already. Others, I would advise do it one more time. And some of you are saying it is impossible to work on it. 2 students have written, sir, not enough information. No, there is enough information. Okay, so let's work on this question together. Pause the video. If you have not got enough time to work on it, pause the video. Do not see my solution. Work on it yourself. Maybe you can take 5 minutes on this. Work on it on pen and paper. Scribble it down and find the match here, A, B, C, or D, and then see what I'm going to do. I really highly advise you to do that. Do not depend on me. You have to depend on yourself. Okay, so assume you have paused the video, tried yourself, let's work on this here. A force F1 acting on a body of 2 kilograms. There are 2 different scenarios here. 2 kilograms has a force of F1 acting on this. I highly recommend you making pictures, you don't have to. But this is going to really help you. Acceleration is 2.5 meters per second square. That is scenario number one. Now, another force, another color. Let's choose green. Green color body is 5 kilograms. Okay, now there is a force called F2, and then it produces an acceleration of 2 meters per second square. Now, write down the goal. The goal is this. I will highlight with the red color. Let's use all the colors available here. Force 2 divided by force 1. So how about I find the force 1, I find force 2, and then take a ratio of that. So let's do things in sequence here. So the force 1 is equal to mass of the first body, which is 2 kilograms, multiplied by the acceleration of the same body, which gives me 5 newtons. No big deal there, right? Now, as I'm doing this, many students are already writing on the chat box, and this is what I call active participation. Like you're participating in the class, you're learning more. Now, the second force is second mass multiplied by the second acceleration, but that gives me 10 newtons, and the answer is so obvious here. Right, so I have to find, this was the goal of my life when I solve a question, that is the goal of my life, right? So goal of my life is F2 by F1. F2 is 10 newtons divided by 5 newtons. 10 bata 5. Newton cut gaya. This goes off, and that is the reason I actually write the units also. This gives you 2, and what is the unit? There isn't any unit. It is a pure ratio. So the answer here is A. I can still see students saying, yeah, sir, I got the right answer. Good job there. Good job. Excellent. Super duper easy for you now, right? So you have taken maybe 4th or 5th step by now. In next 3-4 steps, you will achieve that. And please stay tuned for the surprises as well. But more than that, you should also be waiting for the surprise, not surprise, but the challenging questions that we are going to do. And you would not have been able to do those questions now. Okay. Okay, yeah, I can already see the answers there. Thank you for that. Again, you're going to use F equals to ma, and then you're going to use whatever 3 equations of motions you learn. Yeah, pause the video if you have to. Pause the video, take as much as you want. I'm again telling you, if you see my solution before you try yours, the guarantee is not valid. If you try yourself, I can guarantee by the end of next 25 minutes, you're really going to be able to do any question on second law of motion. Okay, so assuming that you've already worked on this, let's start doing it together. So again, pictures here, pictures really help. So body of mass 1 kilograms, that's an easy mass, kept at rest. Right, so it is at rest. Now constant force of 6 newtons is acting on this. The time taken by the body to move a distance, so you have to move the body at a distance of 12 meters. How much is the time taken? How much is time? And the body was starting from rest. So what I do is I write all these words around the body so that I don't miss anything in the question there. अब देखते हैं क्या करना है. The very first thing you do is you write F equals ma. Force is 6 newtons is equal to mass, which is 1 kilograms, times acceleration, which is unknown to me so far. तो भाई आ गया, acceleration आ गया, 6 meters per second square. आ गया सबका acceleration, ठीक है. अब देखते हैं दूसरे वर्ड में जाएंगे. Now we'll go to the rest of the question where you have to find this time, distance, and all that, right? This gives you a clue, one of those 3 equations in there. So as I said, just write down these 5 variables. Whether or not you know the values or not, good idea to write them out. Now start filling in the values. This thing tells me the body started at rest. Good. So just fill in there. You have to find the time. For the body to move 12 meters, what I'm doing is I'm reading all this information and plugging in the values filling in the values, not plugging in the values, but filling as of now. And then we'll go and plug in these values in one of the equations. Now the acceleration I calculated just now, 6 meters per second squared. हो गया ठीक है. So now USAT, which equation is that? Thank you for responding there. It's the second equation where S equals UT plus half AT square. No, it's not V is equal to U plus AT as many students are saying. As you don't care about this, right? So you don't care about V is equal to U plus AT or V square minus U square, because I don't care. And sometimes if it doesn't work, you write it, I don't care. I don't care about this variable. Nowhere in the question it is asking, and I don't care. I don't have to calculate that. Okay. So then you go ahead and plug in the values. Displacement is 12. So plug in 12 there. Equals UT 0 multiplied by this was T, and T has to be found, right? So F, I, and D, right? Fine. So 0 times T plus half times acceleration is 6 times time squared. ठीक है. अब 0 times something is 0, so I don't even care about this thing. Now this 2 will go up and get multiplied, and it will be 12 times 2 over 6 equals t squared. 2 कटा 2 बन गया, 3 बन गया, 3 से वो 4 बन गया, right? So t square is equal to 4. The answer to this question is 2 seconds. And I can see many students, by the time I was writing this, many students have written 2 seconds. Couple of the students just wrote number 2 there. You're supposed to write the unit of measurement. It's very, very, very important. I repeat, it's really important. Let's go to the next page. Okay, pause the video. I again advise you, pause the video. Do not see my solution before you do yours. I'm giving you few more minutes here for the students watching live. For the students on YouTube, just pause the video. I can already see the right answers coming in. Yeah, this is a difficult question. Take your time. You should take your time here. Okay, so a man pushes a box of 10 kilograms. So let's make the box of 10 kilograms. This is the box of 10 kilograms, right? With a force of 50 newtons. This is 50 newtons. Okay. There is a friction force of 20 newtons. See, that is the beauty of making these pictures, because now you can visualize. If the box is going this way, so let's say this is the box, it's moving this way, the friction goes backwards, right? So you don't have to study friction for this, but at least you should have an idea that the friction force is going piche, ulta. So if you're sliding forward, the friction force is saying stop, stop. So few students are saying, so please give a brief overview of that. So I'm doing that. So let's say there is a box here, and it's moving in this direction. Friction force doesn't like your motion. It says, I'm going to provide a friction force here and then make you slow down and then stop. If you're moving this way, the friction force is again ulta. It is always going to stop you. It's a destructive force, right? Please remember that. And that's all you need to know for now. Okay. So then let's revisit the question. A man pushes. So where is the man? One student here is saying, sir, aadmi to banaya nahi idhar. So this is the man, right? So pushes with 50 newtons, right? This is the man with a green color shirt. He is pushing with 50 newtons. Friction force says, no, I'm going to oppose whatever you're doing. So providing backwards, right? Find the acceleration of the box. Go back and write the same old equation. We have done it already 7-8 times now. You're going to use maybe 200, 300, 2000, 3000, 4000 times in next few years. F equals ma. A force kitna hai? If you think about it, take this box. I'm pushing with 50 newtons here. Somebody is pushing with 20 newtons here. 50 either, 20 either, total is 50 minus 20, isn't it? Now, that tells you the force is 50 newtons minus 20 newtons, because ulta force lag raha hai, rok raha hai usko, right, is equal to mass. Mass is 10 kg. times acceleration. So 50 minus 20, like terms can be added or subtracted. 30 newtons is equal to 10 times of A. So acceleration is equal to 3 meters per second square. Okay, for the students who did not do this or give me the response, have you understood this? Okay, yes, coming up. Okay. Okay. For the students watching on YouTube, you can pause this or rewind this and watch it again. Make sure this is clear. This introduces a new concept of friction force also. We are going towards what we said, the perfection goal. Okay. Now here is something that is I would like to talk about something for next 3-4 minutes. There is a course that is coming up. It's called Score 100% Marks in Force and Laws of Motion for CBSE 9th. Right? If you really want to succeed in your exam or you really want to see, I'm trying my best to squeeze in everything in 60 seconds or 60 minutes here, right? So I'm going to make you an expert still. Even if you don't go for this course, there's nothing like a catch. I'm saying you got to join the course. Even if you do not join the course, you're going to become master in second law of motion today itself, right? But there is a course that is coming up and we are going to do more questions after this. I'm going to talk on this for 2 minutes only. So there is a course that is coming up at Vedantu. It's called Score 100% Marks in Force and Laws of Motion for CBSE 9th. It is a 7-hour course. Whatever you learned in 60 minutes right now, you are going to cover 7 times of that. Now, few students are already writing, if I'm already master here, why should I join the course? You join the course because we are going to be masters of second law, but not all the parts of the applications of that, right? This is a huge amount of what I would say is there is a lot of scenarios. There are so many scenarios that we have to cover in second law, first law also, third law also, and then apply them in the real world examples out there, and also do past year question papers and get a feel of how the IIT questions are. How do they? And in the course, I'm going to make you some of the questions that actually came in IIT JEE exam and also NEET exam. And that is the purpose of this course, right? And I will be there. This is hidden there. I will be there for you. I am the one who's taking this course. So I am one of the master teachers at Vedantu. So master teachers, if you do not know, there are a few teachers that Vedantu has chosen. These are the super experts in their area of whatever they teach. And then these are the teachers who usually take master classes. This particular course is being taken by me. So all 7 hours, I am there for you. Right? Guaranteed. Now, other reasons to join here. Master laws of motion with master teacher, that I already covered, right? And that is me, by the way. There's no other teacher taking these 7 hours. All the 7 hours are taken by me. 7 hours of live teaching. Some of you are watching this on YouTube, so you're not able to directly interact with me, right? Over there, we are going to use go to training software where you are actually going to type the doubts that you have on the chat box. As I speak here, I read some of the students are already doing that right now. So you chat with me live one-on-one. It is not going to be a recorded class. It is going to be a live class. I'll be speaking here in Chandigarh. Wherever you're sitting, you're live connected with me. All of you who joined that. Right? Lots of questions. Today we are covering 7 or 8 questions. We will do a lot of questions in those classes also. But in addition, you're going to get post class assignments. Like when the class ends, I'm going to assign you assignment which may be 10 questions, 15 questions, and then you also get a unit test on that. So where you actually get into a simulated environment where you're sitting in a test center and then you do the questions as a real exam there. In addition, this is another big reason to join. You become part of an exclusive WhatsApp group. So WhatsApp group, there's a WhatsApp group where you all will be connected with me and other experts in there, and you put in any doubt that you have related to laws of motion, or maybe some other physics doubt also you can put in there, and it's 24/7 guidance. I mean, that doesn't mean that 3 o'clock you post something and you get a reply by 3:1, but then you really get very fast responses there. Students help each other, I help you, and many other experts help you out there. So 24/7 guidance available to you. And that this WhatsApp group is only by invitation. So if you join the course, you're part of that. Now, another thing is you can replay the class anytime. Why would you replay? Let's say you attended the class and then you did not understand or you wanted to go in depth of one of the questions there, you can always go back and replay the class. Another reason might be you already studied now, your exam comes up in 2 weeks from now. Sorry for that. So you might want to revise that. You can always replay the class anytime you want. Or maybe you're absent or your internet goes down, electricity goes down, you're sick, which I don't want you to be, but something happens, you're not able to attend the class. All 7 classes, all 7 hours of recording is available as a recording later on, right? Now, what is the surprise? Surprise is the regular price of the course is 1500 rupees. It's 1499. Today there is a lightning deal, and this deal is not for your friends. It's only for you, the students who are attending the webinar here for next 1 full hour. Not next 1 full hour, but the full 1 hour. You get this deal for 499 rupees. Only for next 4 hours. The price will go up after that. It may go up after that. So there is no guarantee after 4 hours. So after not now, 4 hours from the time that the class ends now. So your counter starts 10-15 minutes from now. So do not rush and start making the payment. Stay there. We are going to do more questions after this. So how do you register? There are 3 messages there. How do you register for the course? Here is the URL for this. Take a screenshot of this. Take a screenshot or maybe just note it down somewhere. Okay, take a notice of this, take a screenshot of this vdnt.in force 9 and it is case sensitive. So https://vdnt.in force 9, that is the URL. You go there, you're going to see the option to make a payment, but the price is usually 1499. This was one of the surprises I was giving you today. Surprise, you're saving 1000 rupees right away, 499 rupees only. So assuming that you have already taken note of that, let's go to challenges there. And this is where we are going to do really difficult questions. Challenges coming ahead. Take the challenge and try this question. It is going to be a piece of cake for you. Take maybe 3 minutes here, 4 minutes here, and YouTube audience, you can pause the video. Take a challenge. You got to do this question. And I can see many students are saying, sir, give me another 60 seconds. I'll do it. Yeah, take your time. Okay, 1, 3, okay, 4. Okay, I can already see 7 responses there. And believe me, this is a very difficult question for your for the level of 9th grade. This is like difficult level question. I can see 11 responses so far. Out of those, 1 is wrong. Yeah. So revisit. So the person who has given the wrong answer, you have done a calculation mistake. I can see that. You are on the right track. You're making a calculation mistake. Another answer with no unit, but the answer is right. Yes. Good job. 17 responses here. 14 are right so far. Good job. Awesome job. So YouTube audience, please pause the video and then watch what I'm doing. So a man pushes a cart. Okay, 29 right responses so far. I mean, it wasn't a piece of cake. Okay, a man pushes a cart with a force of 100 newtons. Friction force is 40 newtons. If the cart has a mass of 30 kilograms, find the distance traveled in 5 seconds. I got to find the displacement in 5 seconds. Yes, thank you. Your answer is right. So more than 30 right answers so far for a difficult question. This is a very difficult question. Okay. Now let's see how to do this. You start by writing F equals ma. For sure, you got to do that. So force is 100 newtons is equal to mass times acceleration. No, this is a mistake many of the students have done. The reason I wrote it like this, because the answer I saw is what you're doing here. You don't do that. You actually say force as in the total force acting on the body. 100 newtons acting here, 40 newtons acting backwards, right? So you got to take everything into account. So 100 newtons, this is what you write, minus 40 newtons, this is what you write, is equal to mass times acceleration, which is unknown to me. So this comes out to be 60 newtons is equal to 30a. This gives me acceleration of 2 meters per second squared. आ गया, एक्सेलरेशन आ गया। अब हम काइनेमेटिक्स में जाएंगे। वी विल डू द थिंग विच वी डू हियर, यू वी ए एस एन टी। ठीक है, ये लिख लिया एंड देन यू स्टार्ट डूइंग। एज्यूम द कार्ड वाज इनिशियली एट रेस्ट, गुड जॉब, जीरो देयर, राइट। एक्सेलरेशन अभी कैलकुलेट किया, 2 meters per second square. Displacement you have to find. Time is given to you, 5 seconds. Now tell me quickly, which equation? Yeah, इसमें v नहीं है, तो then you have to use s equals ut plus half at square. So s equals ut plus half at squared is equal to 0 times 5, ठीक है, plus half times acceleration which is 2 here times t squared, 5 squared. So 0 to cut gaya, doesn't even matter. Half times 2 is 1 and 5 square is 25. So 25 meters, and most of the students, I can see 40 plus students have given the right answer so far. With minority like 5 or 6 making either calculation mistake or maybe they didn't get the approach so far. 40 students, more than 40 have given the right answer. Okay, let's do the next question, and this is going to be more challenging. I'm giving you bigger and bigger challenges in life, you know. Pause the video. Everybody watching on the YouTube, pause the video right now. I mean, I'm really surprised I've already got the right answers here. I'm really surprised. I was not expecting so many responses. I was expecting responses, not these many. So pause the video if you have not done this, and I'm going to start doing it for you. So there's a player here, but he catches a cricket ball. Ball aa rahi hai, and you catch it, and then you stop it, right? That's how it works. The ball is moving, and then you stop it, right? So the ball was coming to him. Let's make the ball here as 20 meters per second. ठीक है, ball का mass है 150 grams. ठीक है, it's coming here, and then you stop it within 0.1 seconds. तो अब देखते हैं क्या करना है इसमें. दिस इज रियली डिफिकल्ट क्वेश्चन. फाइंड द फोर्स. सो लिखो F इज इक्वल टू ma, लिख दिया. फोर्स तो फाइंड करना है. मास पता है, मास इज नॉट 150, मास इज 150 by 1000 multiplied by a, acceleration. अब हम stuck हो गए, right? There is one equation with two variables. I will not be able to do this. But then don't give up, because you can calculate acceleration with all the other parts. So अभी हम क्या कर रहे थे? We were using F equals to ma, using acceleration here into the kinematics equations. Now we are going the ulta, opposite route. We will find the acceleration from there and use it into F is equal to ma. So let's do that with maybe green color. U, V, A, S, and T. I know U is how much? U is given as 20 meters per second. And time is given as 0.1 second. Acceleration pata karna hai, so write fine. Now we are stuck because there are two values known to me. I should be having 3 values here. Third value is, thank you for responding on chat messages. Final velocity is 0. As soon as you say the body is stopped, the final velocity is 0. Which equation now? Yes, V equals U plus 8. Excellent job there. So 0 is equal to 20 plus acceleration is not known times the time, which is 0.1. Calculate acceleration is minus 200 meters per second square. Minus means it's a negative acceleration. It is retardation. But then we can ignore that in the calculation here. So now I will fill in the acceleration. Force is equal to 150 over 1000 times acceleration. Acceleration I get 200. So then you use another ink here, maybe cross, 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 cross. Zero sare cut gaye, right? So force comes out to be 30 newtons. Piece of cake for you. Now here is the surprise, the second surprise coming up for you. The second surprise here is, क्या है बताओ? एक और surprise. Anybody on the chat box, what is the second surprise? Second surprise is you did an IIT exam question just now. This was asked in year 2006. You can Google and see the test paper of year 2006. This question came in IIT. And what grade are you in? You are in 9th grade. When do you give IIT JEE mains exam? You give in 12th grade. Are you not able to do a question that you were supposed to or expected to do 4 years down the line? You're already there. Right, that was the surprise I was talking about. It's I would say this is a bigger surprise that you already did. I mean, I can see 30 plus responses so far. I think 32 responses, I'm counting still there, who have already given the right answer. And some of the students have said, "Sir, I got the right answer already." Congratulations, you're already there, right? So that's one another reason you got to join the course. And join it because there is also a satisfaction guarantee. There is a guarantee, I can tell you, money back guarantee. It's not like Amazon or Flipkart, it's like that, you can say, right? It's there is a money back guarantee. You join the course with 499. It's a tiny amount, or maybe may not be, but then you join the course. If you're not satisfied, no questions asked, you will get the money back. And I'm not lying on that, because the fact is, first of all, you'll never do that. Because if you take one or two classes, you would like to attend all 7 classes. But still, for whatever reason, your schedule clashes, maybe you're not getting the time to join, or for whatever reasons, you're going to get your money back. So that is guarantee number one. Guarantee number two is there is going to be enough of the fun in the class. So note down the URL here. Note it down, note it down, note it down, and join there. अच्छा, मुझे एक दो आए हैं, like two students have asked, sir, what is the special thing about this number 499? Why is it 499? So let me answer that also. Why 499? Just a humor there. There's nothing much. But why is the price 499? Wanted to beat the price of Geo offer. Now, you know, Geo phone is available for 501 rupees, just beating the price, right? So honestly, this is just a joke, but this 499 is the reason for that is it is more affordable. Had the price been 1500 rupees, which is 1499, this is the regular price, many students can afford that, and many enrollments have already happened. But in order to help many students who cannot afford that price, the price has been reduced to 499 for the students who are actually part of this webinar today. And this is only for next 4 hours. So next 4 hours you got to register for this, and then you get the lightning deal as 499. So I'm hoping that I'm going to see you soon in the class. With that said, I don't want to say goodbye here. I want to say I will see you soon. So please read the nice message in here. Do not limit your challenges. Challenge your limits. Your limit maybe you want to do IIT, you want to do medicine, you want to do physics maybe. I mean, I love physics. I would like to see you maybe doing PhD, do some research, come up with something new out there. So whatever your goal is, those are your limits. Challenge those, but the step has to be like step one, step two, step three. So I'm going to see you. I love teaching all of you. I love teaching physics, right? I would see you very, very soon. With that said, thank you. Bye bye here. It was really nice of the audience here. Thank you for responding. Everybody did so well. You responded, and I can guarantee any question out there in second law of motion, you can do that. And if you want, you can rewind the video and see whatever part you want. So thank you.